Derivatives of other trig functions. So in this lesson, we're going to be looking at the derivative of tangent and cotangent, cosecant and secant. And along with that, we will be looking at the product rule, using the product rule and the chain rule as well. So make sure that you have your formula page handy. And in this first example, I have four examples. We need to use the product rule. Now the order that you use the product rule doesn't matter. As long as you apply it correctly, because you are adding in the middle, so you can either take the derivative of the first term and leave the second term, or take the derivative of the second term first and then leave the first term. So as long as you know how to use the product rule, and this is how I chose to do the product rule. Leave sine x, the derivative of tan x is secant squared x, plus the derivative of sine x is cosine x times tan x. Now I'm going to change in the next step tan x, I'm going to change it to sine and cosine, because as I look ahead I see, okay, well if I change tan x to sine x and cosine x, my cosine x will cancel. And then I'll remove a GCF of sine x from both terms, and I'm left with secant squared x plus 1 in brackets, and this is my final answer, because secant squared x plus 1 doesn't equal anything. In example 2, it says differentiate secant squared, and I have 3x minus 1 in brackets. So remember that since it's secant squared, I can rewrite this. So I'll rewrite it as secant bracket 3x minus 1 all squared, and then I'll have to apply the power rule when I take the derivative. So if I'm taking the power rule, the 2 will come in front, leave secant 3x minus 1, subtract 1 from the exponent, so it's left to the power of 1. And then I need to take the derivative of what's inside. So times the derivative of what's inside. The derivative of secant, according to my formula page, is secant 3x minus 1 times tan 3x minus 1. And the derivative of what's inside of that, the derivative of 3x minus 1, is just times 3. So take a look at that again. You can see that for the derivative, you apply the power rule, take the derivative of secant, and the derivative of secant is secant x tan x according to your formula page. So you have it secant 3x minus 1 times tan 3x minus 1, and now you take the derivative of what's inside, so that's 3. And that's how I got that first statement of the derivative. Now I'm going to simplify this a little bit. 2 times 3 is 6. And then I have secant squared 3x minus 1, because you can see how in the first derivative that I've taken, secant times secant is secant squared. And then times tan 3x minus 1. And there's your answer. My third example says take the derivative of x squared times cosecant 5x. So again, I'll need to do the product rule. And I'll leave the first term, take the derivative of cosecant, and according to my formula page, the derivative of cosecant is negative cosecant 5x cotan 5x times the derivative of what's inside, which is 5, plus the derivative of x squared, which is 2x, times cosecant 5x. And I'll simplify this a bit. You can see how I have a negative x squared and then the 5, so that becomes negative 5x squared, cosecant 5x, cotangent 5x, plus 2x cosecant 5x. And I do have a GCF here, so in my third equal sign, I'll factor out a cosecant 5x out front. And I also have an x that's common as well. So between the x squared and the x, I can take that out as well. So my GCF is x cosecant 5x, and what I'm left with is in brackets, which is negative 5x cotan x plus 2. Last example, it says use implicit differentiation. So anytime it says that, I know that I have to take dy dx to find the derivative with respect to x of tan x plus sine y equals 1. So the derivative of tan is secant squared. The derivative of sine y is cosine y dy dx. And the derivative of 1 equals 0. So since I'm solving for dy dx, I'll move the secant squared x to the other side, and if I do that, that becomes negative. Divide by cosine y, because it's cosine y times dy dx, so the opposite of multiplication is division, and there's my answer. So dy over dx equals negative secant squared x divided by cosine y.